Okay, now you already know how to glow discharge grids. Our grids are ready. Those are our grids. You know that. So there are 3 or 4 grids are there. Now what is required to freeze our sample? Most important part, this is the setup it is required, where we are going to add liquid nitrogen here. So we'll show you how to assemble this. Here, this is the place where we are going to keep the grid box. In class already I showed you what is called the grid box. Here I am going to show you the grid box also. Here this is the grid box. Now in this particular setup, here you can see a hole where there is a brush container is there. We can keep it inside here. That will assemble later and I'll show you. Here there is a bridge between these two, or you can tell that this is a spider which is going to connect your liquid nitrogen and this container. We'll assemble these things again later. First let's see what is required for our work. Now in this grid box you can see there is a screw. So I need a screwdriver, because entire thing we are going to do it in presence of liquid nitrogen. So we need a proper screwdriver, because this screw we cannot open it. So when it will stay in liquid nitrogen, we have to open this screw. Now if I just open this screw, what you can see, you can see there is a 4 empty places, 1, 2, 3, 4, where your grid will go, because you already glow discharged 3 grids, that it will go here 1, 2, 3, 4. And when grids are inside this grid box, you use this transparent lid and cover this one. Why this is transparent? Because if it is not transparent, you cannot see your grid properly. That is the reason it will be better if you have a transparent cover. Now, when it will stay in the liquid nitrogen, it will be very difficult to see which one is the empty place. There you can see there is a one small notch is there, or an empty area where you can take out grid from this one. That is the reason here you have an empty place. What we can do, I already discussed this. This is the grid box and this is the cover. Cover you can see it is a very transparent one. So what I am going to do, when I will take the grid box, first I will label this one like this, blue. So I am keeping a marker here. So at liquid nitrogen condition, I can find out the empty spot here. In this one you can see it, that, right? Now if I put this one here in this grid box, you can see where that mark is. That is the reason we are marking in this way. So when this is done, we'll close it. So whenever we'll insert this grid, you keep it little bit loose, so this lid can easily rotate. If it will not easily rotate in presence of liquid nitrogen, it will be very difficult for us to freeze the grid and transfer into this grid box. Why do we have to cover this lid? Because it is better to cover it, then ice contamination possibility will be less. There is another types of grid box are available, where you can completely remove this lid and you can put it later. But that kind of grid box you cannot protect that. This kind of grid box we always use, so we can avoid the ice contamination. You can see it wherever grid is. If this grid is frozen, we have just moved this one, so this particular part will be covered. Again this particular part will be covered. So your grid will be not coming closer to air or any ice contamination. Your grid will be protected. That is the reason we are generally using this kind of grid boxes. Now couple of more things. We need a very fine tweezers because we have to deal with grids. Details about these tweezers you can find out here. Bottom it is written, or any book or manual you can find out what is required. You need a very sharp tip. Next one, this is a Vitrobot tweezer. It's a very sharp tweezer. Here there is a clip here which is helping us to hold the grid, and at the bottom, at the top, you can see there is one groove which can go and fit here in the Vitrobot. So those are the tools are required when we will freeze our sample. Now, here you can see one container is attached where we can add water, and that can maintain the humidity inside this chamber.
So in the last session, as we discussed, what are the things we need for the freezing, whatever the sample we are freezing, that is called plunge freezing. In that thing, whatever materials we need and all we discussed. So now we will see how we will pre-set up the things, the Vitrobot for the freezing. So this Whatman filter paper we can use for the Vitrobot things. So this we can purchase from the Tetpella and also from the EMS. This groove and all the thing that can fit into this Roboticam, whatever is used for the blotting out. If you open this chamber, this is the pre-humidified chamber. We can maintain the humidity and the temperature and all the conditions, what conditions we need for freezing our samples and all that. So here when we come close to here, there are two arms will be there. The two arms that will be blotting out excess of your buffer. Then as a result your sample will be blotting, so you will be getting out the amorphous size. So here we can see that attached filter paper, that one we can remove from this clip. There are two clips will be there on the opposite sides. So we can remove gently without disturbing this arm. Okay, so the reason behind that is this will be attached with some specific calibrated parameters. So in that way that parameters should not be disturbed. If we are removing these things very harshly or anything, that parameter will be disturbed, and then it will take months to again optimize which parameter will be working for our sample generally for getting the proper ice thicknesses. So when we are removing, we have to remove this one very gently. So once you removed like this on the same way on the both the directions, you can see that old filter paper is attached onto this clip. Okay, so when we are putting that the new filter paper, we have to be careful about the filter paper should not be bent, because it needs to be uniform, then only the blotting will be also uniform, or else if it is bent or anything, means as a result it will blot the things, it not very properly according to the parameter you are setting. So you have to put this one in the rim like this way, then gently push all over the area. Your force should not be uniquely present onto the one area, it needs to be distributed properly. Once you put like this, it will go inside. So like this way, your hand also need to touch here only. Also it is a good practice to wear the gloves so that your hand dust or anything will not be contaminated in the blotting paper. So once you put here, you can gently move that one and then press that onto the corner, on all the corners. So as a result you will be putting the Vitrobot filter paper. So in the same way you have to put on the other direction also. So now we successfully put this Vitrobot paper, filter paper on the both sides without bending the things and without disturbing the actual fine element. So now we can close this chamber. Once we close this one, now we have to make sure that this humidified chamber the water needs to be filled needed level. So as a result, so we have to remove this one also for each per week or like that. We have to remove the clean the waters and all that. So when I'm removing this chamber, you can see here water is there. Okay, so every week once we have to clean this water also. Once that one is cleaned, and then we have to fix it like this way. So once we put onto the groove, then we rotate, means it will fit accordingly. So once this one is done, we have to take the milky water, like the double sterilized water or anything. So we have to take this, and then we can connect this syringe, and then we can fill this water into this humidified chamber. Once we connect it, then we can use of this syringe, we can put this water. So like this way, until it is full, we have to repeat filling the water. So now we changed the Vitrobot filter paper, and also we filled this water into the humidifying chamber. So now from this way, the water will be taken, and then it will use that water for making this chamber pre-humidified. Whatever the humidity we needed, that condition it will be maintained for the freezing. So now we can turn on this Vitrobot freezing unit. So what the idea behind that is, now we have to set the humidity to be 100%. As a result, it will maintain the humidity inside this chamber. So whatever the filter paper we attached, that one is dried, it is from the room condition. So if we are directly blotting, it will suck away your sample much more than your expectation. So you need to keep that one in under humidity condition for some time. So as a result, it won't be that much dried, and it won't blot your sample fully also. Okay, now the freezing unit is ready. We can set up the parameters whatever the user needs actually. So when we have a closer look on what are the parameters we can set for the freezing. Now we will have a closer look onto the parameters what are all the available for the freezing things. So first we can see the temperature change. Whatever the temperature we can, for example your sample is specific for some temperature, we can set from the 4 degree to 60 degree, you can set accordingly. Generally most of the samples won't be that much specific for the temperature, because we are giving just a fraction of seconds before freezing for this temperature. Okay, so here we are keeping as it is. Next one is humidity. Here as I told you, we have to keep that humidity to be 100. Okay, so manually we can change it to 100 like that. Then we can set that humidity 100%. There are two options either, one is manual way and another one is on. It will be automatically maintaining the humidity. Okay, so first before giving humidity, first we have to close this chamber also. There will be a small hole here in for the robotic arm to move in and out. For that, first we have to close that one. Before that, first I will finish that what are all the other options are there. So that the movement of the robotic arm for the freezing and all that, we can either control by use of the foot pedal. So in these controls, you can see that there are options to control the movement of the robotic arm. There are two ways to control the robotic arm. One way is this use of this control, and another way is the previously seen that foot pedal. Okay, and so other than that, when we come onto the options portal, there will be several options will be there. So first we will see the blot time. Blot time is nothing but how much time it needs to blot the sample. Okay, so and the second one is wait time. It means that how much time we need to give the duration before the blotting will be applied. Means once first you will apply the sample, then you will be waiting for the how much time it need to be waited before the blotting will be happening. Okay, then the drain time is how after blotting how much time we are giving for the sample to be on the grid before freezing. Generally we won't give the time for draining time. So blotting time is very specific for the Vitrobot machines whatever you are using. And then the wait time also will be constant only most of the time. When coming to blot force, it will be either way in the positive or negative way. If it is in the positive way, it will be forcefully blotted onto the sample. If it is in the negative way, it will be the force will not be the that much when comparing to the higher positive ways. Then coming to blot total, it says number of blot, how much time you need to apply the sample onto the grid. So that's all about the parameter, and here you can see that how much time you want to blot each blot, what is the blot force you want to use, and every parameter you can customize and add it. Generally we will apply only one time the sample. In such a special case, like for example you have very less sample concentration of protein, like that cases you will go with multiple times you will apply the sample, and then you have to blot every time. But it is entirely depending on your sample. You have to then optimize what is the blot time you have to give. Then basically you have to optimize what is the ice thickness you want to get, like that things. So at the same time, blot force, the one of the application of the blot force is For example, in the case like you are dealing with a complex of proteins, it has a complex of 2-3 proteins. If you are giving more blood force, the complex may be disrupted. So you, in that case, you have to give less blood force. And in the case of like detergent in the buffer, like membrane protein, like that case, you have to give more blood force. So as a result, you won't get the thick ice. So you will be ended up with the proper ice for the electrons to penetrate and imaging your samples. So here you can enable the foot pedal option also. Then foot pedal will be also be enabled. Now once these parameters are set, we can enable the humidity to be turned on. So first we will turn on the manual mode of humidity. You can see the humidity fog is coming inside the chamber. So once this one reaches 100, we can turn on this mode to be automatic mode. So now we will, once this is reached, now I am turning on this automatic mode. So then we will wait accordingly to your instrumental setup. Some people will be waiting for 20 minutes. Some people, here we are following 5 to 10 minutes maximum is needed. So after that we can go for the freezing. So at the same time, if we are keeping this humidity for long time, this will be fully with wet condition. So you can't use that filter paper for anymore for the freezing also. That you have to keep in mind. So once this is ready, we will start setting up the freezing unit. So now we will see how we will assemble the freezing units for the Vitrobot freezing. So as we seen in the last class also, this is the apparatus. You can see this is the Vitrobot freezing unit chamber. So this is called the floater. This is the base unit we will put here. So the purpose of this floater I will tell in the later view. So this is the stage for the where we will keep the grid baths. So this one we have to keep it here, and then this is the ethane container chamber. This will be going into the center of this one. So this is called the spider. This temperature, this spider will be going in the crossway into this chamber. So the purpose of the spider is it will transfer the heat from the liquid nitrogen temperature towards that liquid ethane container. As a result, that will be maintaining minus 180 degree, like that cryo conditions will be maintained for the plunge freezing. Okay, so now I am doing everything for the dry condition of the freezing to visualize properly for your understanding. Then we can go for the liquid nitrogen freezing also. Now we are going to see the entire freezing process in dry condition. Then in the next session we can see the entire process in the liquid nitrogen. Okay, so for the first session, as we discussed, first we made the chamber for the pre-humidifying condition, and at the same time we prepared this setup for the freezing condition also. Then we have to load the grid onto the Vitrobot tweezer. In the tweezer, we should, one important point is we should hold this thing onto the rim of the grid only. So it should not go inside. The reason behind that is if it is going inside, it will crush the layers of the grid. Okay, we have to carefully take this grid onto the rim of the grid. Okay, without going into the center of the grid. Once we taken, based on your left-hander or right-hander, the sample applying area need to be right or left according to your wish. Once the humidified chamber is ready, we will press this foot pedal. As a result, that robotic arm will be come at the down. Then it will enable us to dock this grid tweezer onto that robotic arm. So in this groove, we have to fit that one gently onto that one. Once we fitted, we can press the foot pedal, then it will go inside the humidified chamber. Once the tweezer along with the grid went inside the humidified chamber, we have to keep this setup. So before keeping this setup, we have to remove this one spider before placing this chamber onto this one. The reason behind that is if it is there, when it is going, it will be blocked here. It can't be make contact with that one. So the reason behind that is that floater will help along with the liquid nitrogen, and then it will maintain the temperature within that. Also the humidity, everything matters here. So in dry condition, now when we do, it will go now. Once this chamber went for the pre-humidified chamber, we have to press the foot pedal once again. Then the sample will be, that grid will be coming down. So then according to your hand, we either right hand or left hand, as we decide, we can open this on the side and then we have to apply the sample. Generally we will apply 3 microliter of the protein sample or whatever the biological sample you are handling. So gently we have to go on the right side and then without touching the grit or bending the grit we have to apply the sample. So if you blow discharge the grid properly, the sample will be distributed uniformly all over the grid. That's the another main purpose of the glow discharging. Okay. So once when you apply the sample, we will press again. Then according to the parameters whatever we set, it will wait for 10 seconds. Then again it will go for the blotting of 6.5 seconds. So based on your sample, we have to choose the blotting time. Once this is blotted out, it will be immediately plunged onto the ethane container. Okay, so the sample will be rapidly freezed in amorphous form and it will be staying inside the column. So in this condition, once this comes here, we will transfer from this ethane container place of the grid to the grid bath, whatever in the stage, grid bath stage, there we have to keep it back. So we have seen the overall process of how we will freeze the things and all that in the dry condition. In that one, and another point is the blotting time, whatever we have to decide, it needs to the size of the sample. For example, you are handling with liposome or like that cases, you need thicker ice when that particle need to stay in between the holes. In that case, if you are giving very thin ice like that means, it will not stay. As a result, it will either go to the carbon area or that particle will be disrupted. That is called the air water interface degradation and all that cause. So accordingly, you have to decide blot time, how much time you have to give. For example, you are giving more time for the blotting, the sample will be ultimately resulting in the thin ice. Your grit will be ended up like that. If you are giving lesser time means you have more of the sample will be there. As a result, you will be getting thick ice. So like that way, you have to think about your sample and then you have to decide these parameters accordingly. So the overall process we have seen today in dry condition. In the next session, we can see that everything in the liquid nitrogen condition, how we can transfer the grit onto the grid baths and how we can take that for the next step of the clipping before inserting the sample under the microscope. Thank you. So then we have seen the entire freezing process in the dry condition. Now we can see the things in liquid nitrogen condition, how we can deal the sample freezing in liquid nitrogen conditions in real life scenario. So we have to first take the liquid nitrogen in filtered way. So the purpose of filtering is to get rid of the contaminated ices and all that. If that ice contamination or anything, you are using the old liquid nitrogen also, it may have the ice flakes will be there inside. When we are freezing, that flakes will become as a ice contamination during freezing. It will be a huge problem in the cryo condition when you are imaging the samples also. So this is the filtered liquid nitrogen. We have to pour onto the sides of this container. Once this is everything set up, we have to pour onto the sides instead of the center chamber of the ethane. So once we pour this one onto the side, you can see the entire setup is wobbling because of that liquid temperature changes from the room temperature to the liquid nitrogen. So we have to add periodically until it reaches that one. So you have to keep adding this one. So this bubbling thing, once it stops, you can approximately sure that it reaches the temperature. Okay, this is little bit calmed down now, so you can sure that this is reached the nitrogen condition, means the cryo condition. So once you make sure enough liquid nitrogen is added, you can go for filling the gas ethane. So the process began, that is, here we will fill the gas ethane. As I told in the previous session, the spider will transfer the temperature from the cryo condition of the nitrogen to the chamber. As a result of that temperature, that air of that ethane air gas will be condensed and then it will become a liquid ethane format. So now we will start filling the liquid gas ethane. So to start the ethane gas, we have to start this flow rate of this one liquid gas ethane by opening this, and then by keeping onto the skin we will get to know what is the flow rate. If the flow rate is too much, when we are moving this one, from here to that area, this gas will fall onto that ethane nitrogen area, then ice flux will form onto that area. If that flow rate needs to be proper, if the flow rate needs to it's less, means it will not create the contamination all around the area. So now I am checking the flow rate, use of my skin, then we can go immediately onto that center of that container. Then we have to start rotating these things in the initial phase. In the initial phase, the reason behind that is that change in temperature is happening here. If you are keeping onto the one area, it is not advisable for the conversion of that gas to that liquid condition. So we have to keep rotating these things. And now the flow rate is little bit high, we have to be less. So we have to fill like this way. Once this is filled, you can see the bubbles are coming at the corners of that edge between the spider and the end of that container, ethane container. So you can see that bubbles is coming here. So you can make sure that it is filled under the top of the ethane container. Then immediately we have to take it like this way. So once this liquid nitrogen was filled and the ethane was filled, we have to keep the grid baths. As we seen in the previous sessions, we have to put this lid and then we have to loosely put this screw and then we have to keep in the stage of the grid bath stage. Okay. So once we kept according to the groove, we can fill the liquid nitrogen again to maintain the level properly. So here you can see the ice is started forming. That makes sure, that gives the signature that inside liquid ethane reached the cryo condition, which is proper for your freezing. Then we can remove the spider. Okay. So once the temperature is reached by seeing that ice flakes around that area, we can remove the spider. Then once we removed the spider also, again we have to fill the liquid nitrogen. And main point, whenever we are filling the liquid nitrogen, that filling of liquid nitrogen level should not be overwhelmed onto the ethane container. If it touches the direct contact, it will form the solid ice immediately. So always you need to be careful about that. So use of this floater, we can make that liquid nitrogen slightly in contact with that ethane container. As a result, we can see that whether the container is in proper temperature to go for the freezing. So how you will see that one, that flakes again it will form on the corners of the ethane container. Okay. So now you can see that flakes is forming onto the corners of that ethane container on the edges of the periphery. Okay. So now we can go for the freezing. So once this system is ready for the liquid nitrogen condition, then we can attach this grid as we seen in the dry condition also. We have to attach this onto the robotic arm. Once this is attached, we will press the foot pedal, then it will go inside the humidified chamber. Then we have to keep this one onto that stage of that one. Again we have to make sure that we remove the spider or not. Okay. Once this one is done, we will press the foot pedal. It will go and close this entire compartment in the liquid nitrogen condition, so that there won't be no atmospheric contact. So once it reaches, again we have to press this robotic arm and then we have to apply the sample onto the grid without bending the grid. Okay. So open this side gate, then apply the sample, then again press the foot pedal. According to your parameters, it will blot out the sample and then it will immediately plunge onto the ethane. Now it is there. So as a result, you will get the amorphous size. You are not giving any more time for formation of crystallize. So once it is done, we gave some time to hold it here. That time there was a high chance that liquid nitrogen level will be less. So we have to add little bit of liquid nitrogen. Then we have to undock this grid from here, and then we have to transfer onto the grid bus. Let's have a closer look on how we will transfer the grid from the ethane container to the grid bus. So first gently undock this one. Always whenever we are moving, we have to make sure that the grid inside the ethane container should not touch on the surfaces of the ethane container. Okay, so we have to undock this one gently. Once undocking is done, we have to keep it like this on the support of the side. Then take this entire compartment and go towards the floor. Then transfer from the ethane container to that grid bus. So you have to unlock this one, then transfer immediately onto that grid bus of the group. Now after unlocking, you can see now in the top view how we are transferring from here to the grid bus. The grid bus, you have to, before transferring, you have to make sure that that groove is open in condition to transfer the grid. So immediately, use of floater also, you adjust the levels of liquid nitrogen and transfer immediately onto the groove without damaging the grid, and then you released it here. Once we released, we can close the lid again. Okay, then we will store into the liquid nitrogen condition before clipping. So in today's session, we have seen that how we will assemble the apparatus for the plunge freezing for the preparation of sample for the cryo-electron microscope, and from the assembly part to the how we are freezing and what are all the parameters are involved, what basis we have to choose the parameters, and even though in the dry condition and also in the liquid nitrogen condition, how we can freeze the sample, the first part of the sample preparation for the cryo we have seen. In the next session, we can see that clipping and how we can load the sample for the microscope, and the later classes we can see the data acquisition and all the steps. Thank you.